Okay, Assalamualaikum dan salam sejahtera. Today, we would like to present our group project for software engineering BITP 2213. So, for our group project title is for food ordering system. Okay, for our group project members, firstly, Ezra Javan Karanadihi. The second one, Putra Shafiq Izwan bin Samsudin Surendran. The third one, Sri Raja Muniswaran. The fourth, Nur Zikri Fahmi bin Nur Azlin. And the last one is me, Muhammad Harijani bin Izwan. Okay, now for introduction part. The food ordering system (FOS) is a web and/or mobile-based application designed to simplify the online ordering process from multiple restaurants. This allows customers to browse menus, place orders, make payments, and track deliveries in real time. This document outlines the software requirement for FOS, including system features, functional and non-functional requirement, and users' role. The system support four main users, which is customers, restaurant, delivery personnel, and administrator. It aims to improve user experience, order accuracy, and operational efficiency, excluding inventory or food preparation management.
Next, I will explain about the purpose of our project. The first one, we want to improve ordering process efficiency. We want to make the overall food ordering system faster and more organized. Number two, we want to help customers choose food easily. The system will guide customer to select food based on their taste and preferences. Number three, we want to make kitchen order handling faster and accurate. This will make sure the kitchen get clear order and prepare them quickly. Number four, we want to simplify and improve payment process. This will allow customer to pay using different methods and get proper receipt. The last one, we want to ensure that the smooth between customer, kitchen, and cashier, because we built a system that connect all parties for better communication and service. For scope of our project, we divided into three, which is customer, kitchen staff, and manager. For customer, they can register and log in into the system, browse categorized menu, customize food item based on their preferences, add item to cart, make secure payment, track order status in real time, also receive email confirmations. The customer also can view past order. For kitchen staff, they can receive customer order in real time, view order detail and special instruction, update order preparation status. The last one for manager. Manager can manage menu content, view sale report and analytics, oversees user accounts, which is for customers and staff account, configure promotions and loyalty program, and the last one, the manager can maintain secure access and system settings. For overall description of our project, the food ordering system, which is FOS, is a web-based platform developed to replace traditional food ordering and payment methods. It connects customers, kitchen staff, and management through a streamline. FOS also supports key operations such as menu browsing, order customization, real-time preparation updates, and secure payments. It is accessible on various internet-connected devices. It is scalable, browser compatible, and designed with modern UI or UX standards. The system also integrates with the other essential modules like billing, customer profile management, and delivery tracking to ensure smooth and efficient operations.
Next part is the functionality and usability. The functionality is menu management, categorize item with images, real-time update, order placement that customizable orders alerts confirmation, order management that kitchen staff update and order tracking. Payment processing is the multiple method like a total calculation, email receipt, and customer management is the profile, order history, and feedback and news data. Next is the usability. For the usability, we use the interface that clean the user friendly, like customer can use the system and it will be the user friendly for them, and mobile responsive. Accessibility is a multi-language and screen reader support. Multi-language is give to the customer that they can choose which language they want when the system in system that they want to order when want to prefer which language. And screen reader support is mostly for the disability person also can use. Next, we are going to the system reliability, performance, and security. For the first, we're going to reliability and availability that we're giving the redundant servers, regular data backups, and 99.9 uptime. For the security, we have the HTTPS and TLS encryption, encrypted storage, auto logout, and admin only access. Performance is a loads within 3 seconds, efficient queries, stable under uh, is usage. So now we're going to the next slide. Next is the supportability and design constraint. First, we go to the supportability. It's give the version control and modular updates and bug fixes. Design constraint is a front-end React.js, backend Node.js or Python. Database we use the MySQL or got the extra also PostgreSQL. Payments is the Stripe, PayPal via Secure API, and compatibility is all browser and mobile friendly that customer can access everywhere in all browser and mobile friendly that give the customer easy to access the system and then to order the booking. So it will be give the customer satisfaction.
So next is 3.8, online help and documentation. Includes simple facts and video tutorials, in-app help features like tooltips and question mark icons. Accessible documentation supports screen readers and follows disability-friendly standards. 3.9, purchase components. Payment gateways. Stripe and or PayPal for secure payments. Notification tools, Twilio SMS, and SendGrid email. Hosting service, AWS Cloud for 24/7 availability. Design tools, GitHub for coding, Figma for design. Okay, so now 3.10 interfaces. There are two, which is external interfaces and internal interfaces. So the first one is external interfaces. Secure connection to Stripe or PayPal, delivery tracking with live maps. Then internal interfaces, kitchen dashboard for updating orders, admin panel for restaurant and user management. So 3.11 licensing requirements. Open source code under MIT license. Third-party tools used with valid licenses. All components comply with legal software usage rules. Okay, so next is 3.12 legal and copyright. Follows GDPR and PDPA for user data privacy. Copyright on all original work. Terms of service shown during sign up. 3.13 Applicable standards for security OWASP Top 10 PCI-DSS for payment uh, accessibility WCAG 2.1 AA compliance. So the last one is documentation and APIs IEEE 830 and RESTful API best practice.
For the next part, by the way, I'm Ezra Jeevan Karmanidhi, and I'm going to be presenting about the diagrams that have been involved in this system. So, first of all, I would like to explain about the use case, which is the diagram you see here. So, for this slide, we have four main characters, which is customer, waiter, kitchen staff, and admin. So for the customer use cases, customer can browse menu, which can explore the available food items, place order, which place order includes manage payment and also extends the cancel order and make payment. So customer also can customize their order, cancel their order, and make the payment. So for the next character, which is the waiter, so waiter can view order status and assist with the payment and also serve the order. So the next one is the kitchen staff. Kitchen staff can receive the order information from the customer after the order has been made, and also access the order details to prepare the food. So for the next one, the last one, which is for the admin use cases, admin includes um, generate daily report, which is from the generate sales report use case. From there, you can see that the diagram also includes the generate daily report and also monthly report functions. And also, admin also can manage the food menu, which includes the add item, edit item, and also remove item for the convenience of the admin to edit the menus that they wanted to add later. Also, the slide also includes and extends based on the requirements that are needed in our project. Also, the summary is that we have ordering module, which handles browsing and customization on order placement, and also payment module, which manage direct or assisted payments. Kitchen module delivers orders details for preparation, and also reporting modules which generates admin sales reports, and also menu management module which administer the food menus items. So for the next part, we have context diagram. So why do we need context diagram? It is because the diagram illustrates the level zero content of the food ordering system. Also, it shows the external entities with the system as a single process, and also highlights the data flow between the users and also the central system. And for the external entities and data flows in our DFD, in our context diagram over here, we have customers, which sends customer order to the system and also receives receipt from the system. Same goes for the waiter, kitchen staff, and also the other admins, which means wait for waiters that they can send payment assistance and order information, and also kitchen staff, they also receive the food order, and also the admin also receives the management reports from the system. So for the system responsibilities, we can see here it accepts and process orders from the customers. It also helps to generate receipts upon successful payment, and also provide order info to waiters for serving. And also there are many more details that are being discussed, but not on this diagram, but in DFD diagram. And also for the key data flows, customer order, the main input to the system to initiate food preparation and also payment. So the next one is the receipt, is that it's an output that is confirming successful order and payment for the every order that customer has made. And also the next part is order information, also payment assistance, which explains the flow between the system and the waiter to ensure order delivery and also help with non-digital payments. And also there are many more itself. So why context diagram is matters in this our project presentation, because it gives a high level view of the entire system and make sure to know its boundaries. Also, it also helps to identify who interacts with the system and what information flows in and out of the system. So it also sets stage for deeper analysis throughout DFDs and also use case diagrams. So for the next part, we'll be viewing DFD diagram, which is data flow diagram, level 0, by the way. So for the DFD level 0 um, flow diagram, we used this diagram because it helps us to shows how the food ordering system process customer orders at more detail level. So it also breaks down the system into four key processes that has been shown in between the flows of the external entities and also internal processes, and also data sources, data stores in this diagram. So the key processes that I'm about to explain is about the process 1.0, which is receive and transform customer food order, which receives which a process that receives order confirm with the customers on their orders, and also sends the order info to the kitchen and waiter. And also for the next process is 2.0, which is update goods sold file. This process is important as it records each sales to track business performance. And for process 3.0 is which is update inventory file, which this reduces the inventory based on the orders placed. And for process 4.4, produce management reports, which helps generate daily reports for the admin using sales and inventory data for uh, improvement in the later coming days for the admin. And also for the external entities that have been present in this DFD level 0 diagram is that the same um, characters that have been present in our DFD, in our context diagram, which is customer, waiter, kitchen staff, and also admin. And also, there are new data stores which present in this DFD level 0, which the first data source is inventory file, at which this stores the inventory records, which will be updated in process 3.0. Also, for our data source 2, which is goods sold file, which stores the sale record and also will be updated in process 2.0. So the next one is the important data flows in the system, which is in between customer order and so received. It helps. It happens between the customer and the system. The food order, which sent to the kitchen, the goods sold, and also data in inventory data, which flows into the respective data stores. Also, finally the daily report that is being sent to the admin. So to summarize my diagrams that we have made, to summarize my points that we have for these diagrams that we have made for our food ordering system over here, this diagram helps to visualize on how each order triggers internal updates to sales and inventory records, and how these are used to generate management reports for business decision making. So thank you so much for my part. For our next part,
Okay, now we're going to the testing part for the system. So the project name is food ordering system. Module name is valid login for the website. So this is the correct way to log in to the system. So firstly, we try to the test case ID, the login first. The test scenario is to log in into account and verify the login. The test case is enter valid username and valid password. So the precondition, first, you need to access to the right website. Second, need to have a valid registered account in the website. So for the test step, we enter the website URL. Second, click search. Three, enter Ezra as username. Four, enter BITC S2G1 as password. Lastly, we're going to click login. So the test data, we will display Ezra equal to valid username. And the BITC S21 is a valid password. So the expected result is a successful login. So the actual result in the system is successful login. So the status turned to pass. So the tested by Mr. Harid. So that have the timestamp for the trial. All right. Now we're going to testing for the invalid login into the website. So we have test several testing to the system. So the first one, the test case is to enter the invalid username and valid password. So the precondition for the testing is the same. We need to access to the right website and need to have a valid registered account in the website. So the first step for the first testing, enter the website URL, click search, enter Ezra as username but a different username. So then enter the correct password, then login. So the test data, the username for Ezra is invalid. The password is valid. So the expected result that we need to get from the testing is unsuccessful login. So the actual result we get at the end of testing was unsuccessful login. So the status for the testing passed. Tested by me. Next, for the second test case, we need to enter valid username but invalid password. So the progression is still the same. So we're going to go through to the test tab, enter the website URL, click search, enter Ezra, the correct username, but we change a little bit for the password. So you will get the wrong password. So then we click login. So the test data, the username, valid username, but the password was invalid. So the expected result was unsuccessful login. So the end of the testing, we get the for the actual result is unsuccessful login. So the testing status is passed. Testing very two. Next, for the last testing, the test case is enter invalid username and invalid password. So the both input was a wrong one. So the condition is still the same. So we're going through to the test tab, enter the website URL, click search, enter Ezra as username that the wrong one, enter the BSC1 but the wrong one as password. Then click login. So the test data, both was a invalid username and invalid password. So the expected result need to get the unsuccessful login. So the actual result in the end for the testing, we get unsuccessful login. So the status for the testing is passed. Testing by me too. Alright, that's all for that part. Okay, now for the Gantt chart part, we have planned Gantt chart weekly for the procedure. Firstly, for the dark blue label for Ezra, uh, the procedure that has been done by him is the research and discovery, kick-off meeting, client test software, and final and rectify errors for the system. While the light blue label for Zikri, he has done the research and user research, then the development phase two, review, and for the create report and final report. That for the Zikri part, and for the yellow label for Abinisri. So she has done for the collect requirement, high level design for the Gantt chart, design review, stakeholder approval. For that, she has done for the procedure. Next, for the label orange label for Putra, he has done for the collect requirements, requirement gathering, and framework for the software. So for my part, for Haris, I have done the part for the design revision if needed, the development phase one, and review for the procedure. That's all for the Gantt chart. Okay, for the last part is the conclusion. The food ordering system (FOS) aims to modernize and simplify the food ordering process by connecting customers, restaurants, and delivery personnel through a single platform. With features like real-time menu updates, secure payment integration, and responsive design, the system enhances user convenience, improve order accuracy, and streamline restaurant operation. This document outlines the core requirement to guide the successful development and implementation of the system, ensuring it meets both users' needs and business goals. Okay, that's the end for our presentation. So, from our presentation, that shows that the food ordering system for our group project. That's all. Thank you, sir.